Bismillah ar-Rahman ar-Rahim. Hello everybody. Today inshallah we are going to start our first tutorial uh, relating to chapter 6, which is mainly about uh, trusses. Okay. We are going also to talk about the method of joints, method of sections, zero force members, and the frames. Now, first of all, what are trusses? Trusses are usually like structures used to support the roofs. Okay. they they like consist of zero force members, okay, which means that we don't have any load in the middle, only the loads or the forces are at the joints, okay. So we can replace the zero force members instead of the in reactions, okay, by like a resultant force Fr, okay, and an angle theta. So here at the joints, we only have the axial forces because they are pin connected, okay, pin connected joints, and we don't have any moments because rotations are allowed at the joints, okay. Also, the method of joints, uh, but before I forget, trusses also are used at construction sites, okay, in the tower cranes, also in the electrical transmission lines, okay. Uh, Here in the first method of joints, we should be able to find the internal like loadings or forces, okay, so that we can able to analyze or design the trusses so that we can avoid failure. So we have two methods, method of joints first of all, and later we'll talk about method of sections. Now, method of joints, we have at each joints we have two equations. Okay, we have said that rotation is allowed, so we don't have any moment. So we have only the forces. So we have two equations, summation of x, fx, okay, and summation of fy equals to 0. Okay, now to start solving, so here the maximum number of unknowns in method of joints is what? Two unknowns. So we are going, after finding the reactions, if required, we will start from the easier part, okay? So here, determine the force in each member of the truss and set if the members are in tension or compression. Set theta equals to 30. So here, theta is 30 degrees. Now we can assume for like for each joint that the force in the members, truss members are in tension. And if the answer is negative, we can like say, okay, it's in compression, okay? So here, after finding the reactions, start with the easier part. So here we should find first the normal force of the roller and the reaction at pin A. Now here, if just for your information, if the the roller was straight vertically, okay, no need to find N. We can find only the reactions at A and start from this joint A, and we will get the force member AD and AB. And then we can move to joint B and find BC and BD, and finally from joint D we can find like the force member DC. So we need to find M. But in this case, we must find M because it has a horizontal component, X component, because it will give us the reaction, or it will contribute the value of the reaction AX. Okay, so here we can start with joint A, then joints B and D. So first of all, taking the summation of moments at at joint C, okay, or the roller at C, we have minus 3 multiplied by the distance. Okay, so here is the force. Let me clear this first. So here is the force, 3 kilonewtons, okay? And the distance is what? The vertical distance is perpendicular distance, 1.5. And it's rotating what? Clockwise. So it's negative minus 3 multiplied, negative 3 multiplied by 1.5. And here also we have the force 4 kilonewtons. It's rotating counterclockwise. So 4 multiplied by the perpendicular distance, which is 2 meters, okay? And finally, the vertical reaction AY, it's rotating clockwise, so it's negative multiplied by the distance, which is 2 plus 2, 4, okay, equals to 0. And AX will not contribute or will not have a moment effect about 1C since it's passing through the joint, correct? Okay, through point C. Now we have found the reaction at A, okay? It's acting upwards. And now if we take the summation of moments about point A or the summation of forces Fy, it's up to you. We can find N, okay? Which is the reaction at C. So here, regarding the angle, it's given this theta, okay? So if we make this, the reaction is what? Perpendicular to the surface, okay? So here is our surface, and the angle is given with the horizontal to be what? To be theta 30 degrees. So here is our N, okay? Here is our N, and here is the horizontal, okay? So this theta is given to be what? 30 degrees. So if we make like our 4 axes, this is the vertical axis, this is the x-axis, and this is the axis of the like the n, okay, the n force, and this is our force line perpendicular to it. So here theta is given to be 30. So here also it will be what? It will be theta, which is 30 degrees, and here it will be 30, and here it will be 30. So here theta is going to be what? 30, okay? So here m, it's 30 with the y-axis, okay? So anyway, here we will say, okay, the vertical component n cosine 30, okay, multiplied by the distance, which is what? 4 meters, okay? It's acting or rotating counterclockwise, so it is positive. So n cosine 30 multiplied by the distance, which is 4. Now regarding this force, 3 kilonewtons, okay, the distance is what? 1.5, and it's rotating what? Clockwise, so it is negative. So minus 3 multiplied by the distance, which is 1.5. And finally, this force is also rotating clockwise, and the distance is what? Distance from the force till the point is 2 meters, okay? So minus 4 2 equals to 0 will get n to be 3.61 kilonewtons, okay? In this direction, okay? Now, taking the summation of forces in the x direction, okay, we get what? Plus ax plus 3, okay, and minus n sine theta, okay, because here is the n and here is the theta. Here is our like axis, okay. So here is the vertical component and here is the horizontal component. So minus n sine 30 and n we have found it to be 3.61 kilonewtons, and we will get ax to be what? Negative 1.195 kilonewtons. So it is acting opposite to the direction that we have assumed from the beginning. Okay. Uh, Sorry, here plus ax, okay, minus ax. Yes, correct. It should be opposite to what we have assumed. Okay. Now we are done. We can start like joint by joint. We said we will start with joint A. So we should put out the external forces from the reactions and plus the forces from the members. We can assume them all in tension, and if they give us a negative value, we can say it's compression. So here we have FAD from member AD and FAB. Okay, so FAB, and here are the reactions AX and AY that we have already found. AX and AY. Okay, and here the angle we can find it by saying what? Tan inverse this length or this distance, which is 1.5 over 2. Okay. So tan inverse 1.5 over 2, we can get the angle. Now, applying, we have said that the maximum number of unknowns at every joint is 2 unknowns because we have only 2 equations. Okay. Unlike the method of sections, we can use the moment equation. We will see that later. So here, just apply the equation. We have FAD cosine the angle, we will get positive. Okay. Sorry, here we are starting with Fy. So FAD sine the angle will get the vertical component, which is positive, plus the reaction at AY equals to 0, we'll get FAD to be a negative value. So it is a compression force. Okay. Now, it's up to you. Whenever you get a negative sign, you can redraw the forces at the joint, or you can simply say, okay, I will deal with this free body diagram of joint A, but instead of putting 1.46, I will put the minus sign. Okay, so it's up to the student which like a procedure he prefers. Now, taking the summation of forces in the x direction, we have plus FAB, okay, plus FAD cosine the angle, okay, so plus FAD cosine the angle, but FAD is what? Minus 1.46, okay? If we have redrawn the forces, okay, and put it here as a compression force, it will be what? Minus FAD cosine 36.87, okay? So minus FAD cosine, and here we can say FAD, okay, is only 1.46 kilonewtons, okay? Minus 1.195 equals to 0, we'll get the force. Remember, AB is 2.36 kilonewtons, and since it's positive, our assumption is correct, so it's a tensile force. Okay. Now moving on to joint B. Now we have found FAD and FAB. We have here FAD and FBC. So we have two unknowns, and we have also the external force. Don't forget it. Okay, so here joint B, we have the external force for kilonewtons, FBC and FBD. I have assumed them to be tension forces. And here is our FAB from part A, from joint A, and it's a tension force. Now it's clear that FBC will be FAB in tension. They have the value of 2.36, and FBD will be 4 kilonewtons. Okay, and it's a tension force to be an equivalent at B. And the method of joints says that if the truss is in equilibrium, so the joints will be in equilibrium also. Okay, so we can apply our equations of equilibrium regarding the forces, of course. So here is joint B. Okay, the summation of forces in the x direction. Okay, FBC minus 2.36 is equals to 0. So FBC is equals to what? It's equal to 2.36 kilonewtons. And summation of force in the y direction will get FBD to be 4 kilonewtons in tension. Now, moving on to joint D. Now, here is our joint D, correct? Okay, we have found FBD, and let me clear it. So far we have found what? FAD, FAB, FBC, and FBD. Now moving on to joint D, we have this force, and we can find this unknown, which is DC. Okay, and we are done. So here at joint D, we have one unknown, and we also have the external force, 3 kilonewtons. Okay, but here, the angle here is what? We have found it to be what? 36.87 from tan inverse. So here we can say, okay, so this angle is also what? Theta prime, which is 36.87. And also, because it's a symmetric truss, here the angle is also 36.87, okay? And here it is 36.87. So here tan inverse 1.5 over 2, okay? And here they are parallel, so this angle will be the same, okay? So here is our joint D, summation of forces in the x direction. We will get our unknown FTC. Okay, and theta prime, we have said it is 36.87. So we have plus C3, the external force, plus FDC cosine the angle, which is theta prime, plus 1.46, okay, cosine theta prime. See here, I have assumed it to be in compression, okay? So, sorry, FDC, no here, FD, I think FDA here, it's FDA, and FDA we have got the value of it to be what? To be 1.46 in compression, okay? So I make it here a compression force, okay? And here FDC, I have assumed it to be a tension force, so plus FDC, I got finally the answer to be a negative, so it is a compression force, okay? Now moving on to the next problem here, it's given if the maximum force that any member can support is 8 kilonewtons in tension and 6 kilonewtons in compression. So here it's given the allowable limits for the forces. If we like get a higher value of these limits, failure will occur, okay? Or if we exceed these limits. So we will make sure that any force member, whether it's a tension force, it will not exceed 8 kilonewtons, and if it's a compression force, it should not exceed 6 kilonewtons. So at each here, for any member, so we'll use the method of joints, because we'll get the forces in each member. Unlike the method of sections, it's for a specific members. Okay, so here each member will get the force of it in terms of what? Of external force P. And finally, the highest value of the compression forces, we will equate it by 6 kilonewtons because it's the limit, and we will get the value of P. And the highest tensile forces of all the members, we will equate it by 8 kilonewtons because it will be the critical value, and we will get like two values of P, and we'll choose what? The smallest value of P for safety. So here it's, although it's written maximum force P, but they mean not the value, the maximum force allowed. Okay, so if we have values of two values of forces, we will choose the minimum one, okay, or the less value. So in this problem, the support reactions are not required to find the member forces. You can find them, but it's a waste of time because here we can start at joint D, we will get okay, FCD, FED, then we can move to joint C, we can find FBC, FEC. Then we can move to joint B, we can find FEB, FBA. And finally at joint E, although we should find the reaction here of the roller, okay, but we just want to find FEA. So just we will take the summation of forces in the x direction, and we will get the value, okay, of this force, because here it's only applied in the vertical direction, okay. So here, starting with joint D, the summation of forces Fy will be what? We have FDE, I have assumed it to be in compression, and FDC, I have assumed it to be in tension. You can assume them always to be in tension, it's up to you. And here is our external force. So plus FDC sine 60, okay? So plus FDC sine 60 minus P, because it's acting downwards equals to 0, so FDC will be this value, it's in tension, okay? Now taking the summation of forces in the x direction, so plus FDE, here it's plus FDE minus FDC cosine 60, okay, equals to 0, so FDE minus FDC is what? The value of FDC is what? Is 1.1547 P. So I have replaced it by its value, okay, and equate it to 0. And then FDE will be what? Will be 0.5774 P, okay, since it's a positive value, so the assumed assumption, or my assumption is correct, okay, to be a compression. So here FDE, I have assumed it from the beginning to be, check, a compression force, okay. So if you have assumed it to be a tensile force, you will get a negative sign, and you will say, okay, my assumption is not correct, so it's a compression force. Anyway, moving now to joint C. Okay, I have found FDC. Now I have what? Two unknowns, correct? FCE and FEC. So here, joint C, we have what? FCE and FCB. We have found FDC from part A, which is 1.1547 as a tension force. Okay. Here I have assumed FCE to be a compression force. A compression force. And here it's a tension force. Now regarding the angles, here it is 60, and here it will be what? 60. Okay. Like we have a Z shape. And here also it will be 60. Why? Because here we can say, okay, we have like a F shape. So this angle will be equal to this angle because these two members are parallel. Okay. So now we are ready to apply our equilibrium equations. So summation of force in the y direction plus FCE here, FCE sine 60, okay, because it's a compression force. So plus FCE, it's acting upwards, minus this force sine 60, because it will be what? Acting downwards. Okay, so here is the vertical component and here is the horizontal component. So minus 1.1547 p sine 60. And we get the value to be a positive value. And since we have assumed FCE to be a compression force, so it is a compression or it's in compression. So if a student come and says like this force is a tensile force, okay, he will put here a negative sign, okay, a negative sign, and this will give him a value, a negative answer, okay, and he will say, okay, my assumption is not correct. Here it was a tension, so my assumption, or it should be a compression force. Okay, so it's up to you. Now taking the summation of fx, we have minus FCB, okay, and here we have assumed it from the beginning to be a compression force. So here it will be what? Cosine. So FCE cosine 60 positive. And regarding this force, the horizontal component is what? FDC cosine 60 positive. Okay. So now we are left with one equation, one unknown, and the answer will be in terms of P. Okay, a positive value. So our assumption as a tensile force is correct. Okay. Here you can say, okay, FDC and FCE have the same value, and cosine 60 is half. So 2 of this value over 2 is what will give us the same value. Okay. Now moving on to joint B. Now we are done with what? We are done with this force, this force, this force, and this force. So now at joint B, we can find what? FBE and FBA. Okay. And we have this force that we have found, FBC. So here FBC, we have found it to be tensile force 1.1547 P, and we have FBA and FBE. I have assumed FBE to be a compression force and FBA to be a tensile force. Okay, and here the angle is what? 60. The same thing. Okay. Now taking the summation of force in the y direction, we have positive FBE sine 60. Okay. So here it will be sine 60, FBE sine 60, acting upwards, so positive, minus, because the component of FBA will be acting where? Downwards, correct? So minus FBA sine 60 equals to 0. So sine 60 will be cancelled out with sine 60. Okay, and we are left with FBE equals to FBA. And I said, okay, let's say they are, or they have the value of F. Okay. Now taking the summation of forces in the x direction, we have plus FDC, which is 1.1547 P, okay, minus FBE cosine 60 minus FBA cosine 60. And each of FBA and or both of FBA and FBA have a value of f, so I said minus 2f cosine 60. Okay, so one equation unknown, f is 1.1547p, and since FBA and FBA are equal, so FBE is or will have the magnitude of f, but it is a compression force. I have assumed it from the beginning to be a compression force. Unlike FBA, I have assumed it to be a tensile force, but they both will have a value, the same magnitude, which is a value of f. Okay. Now, finally, at joint E, as we said, no need to find the the reaction here at the roller. Okay, why here the roller at E? Because I am just going to use summation of forces in the x direction. Okay, to find just FEA. So putting the forces at joint E, I have here FEC, FEB, FED, and FEA, which is the unknown. So FED, we have found it already to be what, 0.5774p compression. So here it's 0.5774p, it's in compression. What about FEC? So FEC is what, 1.1547p in compression. Okay, so it's a compression force. Also, FBE is what here? FBE is 1.1547p in compression. Okay, and the angles are 60 and 60. Check here. The angles here will be 60 and 60. We'll have the same angle of these angles. Okay, these two angles. Okay, so we have here a value as Z shape, and here it's also a Z shape. Okay, so summation force in the x direction, we will have what, FEA positive, okay, plus 1.1547p cosine 60, okay, minus the horizontal component of this force, okay, which is minus 1.1547p cosine 60, okay, and finally this force, which is a negative value, okay, equals to 0, we get FEA to be a compression force. Now, from the above analysis, remember we have to find P, correct? And it's given from the problem the limits for the tension, the maximum tension, allowable limit, and the allowable limit for the compression to be 6 kilonewtons, correct? So the maximum compression and tension in the stress member is what? We will check here. Here we have 0.5774 compression. So first of all, let's begin with the tension forces, and we will choose the higher tensile force as the critical one, because here we are in the analysis stage. So we will design for the worst case always. Okay, so let's check for the tensile forces. Here we have 1.154, here we have 1.154, and we have 1.154. So the largest value is what, 1.1547p. We will equate it to 8 kilonewtons. Okay, we'll get the value of P is of 6.93 kilonewtons. Regarding the compression, we will find also the highest value is 1.1547. Okay. Okay, here it's also, here we have a lower value, 0.5774. So we'll choose the largest compression force, which is 1.1547p equals to 6. And we'll note that this is the controlling one, because it will give us the least value, 5.196 kilonewtons. Okay, so choose the smaller value for safety. So in other words, if we choose P to be 6.93 kilonewtons is our limit, when the system reaches force P to be F.196, it will fail in compression. Okay, so that's why we'll choose the lowest value. Now, here is also the method of joint, but we have like a new concept, which is the zero force members. Here, the zero force members, we have like two cases. I have drawn the cases, okay? But here the first case says that if we have two forces, okay, two like force members, two members, okay, and they are non-collinear, so they are not in the same line or the same extension, okay. And the second condition, no external load, okay, or support reaction exists at that support at that joint. So again, if we have two non-collinear members, okay, so they are not on the same line or the same extension. Plus the second condition says if we don't have any external force or a support reaction, so these two members will be zero force members, okay. So they will not have value in tensile or compression, but they exist in fact for stability or rigidity purposes, okay. So here also, here we have two members, not three members, two members. They are not on the same extension or line, non-collinear, and we don't have any external force. Okay, so this member, let's say AF is 0 and AG is 0. Okay, the second case says that if we have three members, okay, so we have three members, 1, 2, 3. Okay, let's see. Hey, here it is C. So we have ED, DC, and AD. But two of these members are collinear. So we can note here FED and FDC are collinear. So they are in the same line. Okay. And the third one, it's not collinear with them. Okay. So this third non-collinear member will be 0. Okay. And here it can be either, it's not a must to be a right angle. So here is another case. Here is another case. Let me choose the green marker. Here I have three members. Two of them are collinear. So DC and CB are collinear. Okay. And the same axis. And here FAC, okay, the third one, which is not collinear with them, will be 0. Okay. But remember, we have another condition that we don't have here any external force or reaction. Okay. Okay. So here we have two members. Here we have three members. Here both of them are non-collinear. Here two of them are collinear, and the third one will be 0. Okay. Here both of them are zeros. And here in both cases, we should not have at the joint here any external force or reaction or a reaction. Okay, so here the solution will be much easier if we like select or identify our zero force members. Okay, because they are straightforward, will be 0, and they will not contribute to the calculation of the forces in the other members. So here we can note what here FED and FDC are two members, non-collinear members, correct? And we don't have here any force, okay? So they are both are zeros. But we have, you can say special case or third case, sometimes, let's say here we are at joint F, okay? If we take the summation of forces in the Y direction, here we don't have any force, correct? But we will have a force from FEF, the horizontal member. But so here we don't have any force, any vertical force. It's 0. So here by default it is 0, a 0 force member. Okay, we can leave it when we do the analysis at the joints. It will appear that it's going to be 0. So here FFA, FFE, and F is 30 kilonewtons. P is given to be 30 kilonewtons. P1 and P2, here P2 is 15 kilonewtons, okay? And what's required is to determine the force in each member. So in each member, we are going to use the method of joins. But here, as we said, the idea, so we have zero force members. Okay. So here, if we take the summation of forces in the y direction, FFA, this the force in this member is going to be 0. So FDE, FDC, and FFA are 0 force members. Now, taking the summation of moments about point A to find the reaction at C. Okay, so we have the reaction at C, okay, multiplied by 6. Okay, it's rotating. Counterclockwise, so positive. And we have this force 15 kilonewtons, the distance is 3 meters, and it's rotating clockwise, so it's negative. Okay, and finally we have what this force 30 kilonewtons, and the vertical distance or the perpendicular distance is what 4 meters, and it's rotating what clockwise, so it's negative. So minus 30 multiplied by 4 equals to 0, and we'll get the reaction to be 27.5 kilonewtons acting upwards. Now, taking the summation of forces in the y direction, we have what? We have already found Cy, okay, and we have minus 15 plus Ay, okay? So 27.5, the Cy, minus 15 plus Ay equals to 0, we'll get Ay to be 12.5 kilonewtons acting upwards. Now, taking the summation of forces in the x direction, we have minus Ax, okay, plus 30 equals to 0, so Ax is going to be 30 kilonewtons, okay, acting to the left, okay? Now here we can start at joint C. Okay, here this is 0. Okay, here we have two unknowns, 1, 2, and we have the reaction at C. So here it is 0. We have FCE. I have assumed it to be compression. You can assume it to be tension, and you will get finally the answer to be negative. Here FCB, I have assumed it to be a tension force and the reaction at C. So taking the summation of Fy's, okay, so minus FCE, here it's minus FCE multiplied by what? The vertical, which is 4 over 5, okay, plus 27.5 equals to 0, we get FCE to be a compression force. It's a positive, but I have assumed it to be a compression force. If you assumed it to be a tension force, you will get a negative sign, okay? And then you will say, okay, it's a compression force. Our assumption was not correct. Now, taking the summation of forces in the x direction, we have what? Here, minus FCB plus FCE 3 multiplied by 3 over 5. So FCE is what? 34.38. Okay, so positive 34.38 multiplied by 3 over 5 minus FCB equals to 0. We will get FCB to be 20.63 kilonewtons in tension. Okay, so our assumption is correct. Now, we have found this force and this force. Moving on to what? If we move on to joint E, we can't solve it. Why? Because here, okay, here it's 0. Here we have found it, but we have 3 unknowns, correct? So we must start with joint B, because we will find FPE and we will be able to find FAE and FE, okay? So at joint B, what we have for external force 15 kilonewtons. We have found FPC, okay, and we will find FBE and FAB. So here is joint B, okay. Here is FPC, which we have already found 20.663 in tension kilonewtons. We have FBE, okay. So FBE and FAB, and we have the external force. So here is FBA and the external force. So it's obvious that FBE will be what? 15 kilonewtons in tension, and FBA will be what? 20.63 kilonewtons in tensions. Now, joint A, now we can move either to joint A or joint E. Okay. So here at joint A, we have this tension, this force member is 0. We have this unknown, okay, and this we have already found it, FAB. Okay, then we will move to joint E and find finally FFE. Okay. But at joint A, we have also the reactions. So at joint A, we have the reactions AY and AX. Okay, we have FAB, which we have already found previously here. It's 20.63 kilonewtons tension force. FAE, the unknown, and here it is a zero force member. Okay. If you left it as unknown, you will find actually it is a zero force member. You'll get a value of zero. So FAE, taking the summation of forces in the y direction, we will have plus 12.5 plus 12.5 plus FAE 4 over 5. Okay, equals to 0. So FAE will be negative. So it is, I have a, it is a, sorry, here I did a mistake. Here it is a compression force because we have assumed it to be what? Tensile, and it's a negative. So it is a compression force. Now, regarding finally joint F, we have what? Here is joint F. We will find FE, FE. Okay, so we have a joint F. Here it is 0. We have FEF and the P value, which is given 30 kilonewtons. So FEF will be 30 kilonewtons in compression. Okay, I have assumed it to be a compression because it's obvious it will be opposite in direction to this force. Okay. Now here the method of sections. Where shall we take the imaginary cut? Here the idea is that we should, it's not required from us to find all the force and all the members of the trusses. In fact, only they will specify for us specific members, okay? So here, for example, determine the force in members ED, EH, and GH. So we are going to take a cut where the unknowns are required from us to find them, okay? So it's not like a good idea to use the method of joints to find the force members here. Okay, you can start here at F, you will find this and this, then you will go at joint G, you'll find this and this, and so on. Okay, so it's much faster method to find here the method of sections. Okay, and you will choose the imaginary cut also so that the maximum number of unknowns will not exceed 3. So the maximum number of unknowns in the section method is 3. Unlike the method of joints, it's only 2. Okay, because we have, we will draw the free body diagram. We will have summation of fx, summation of fy, and summation of moments. Okay, 3 equations. So the maximum number of unknowns is 3. Okay. Uh, Okay, the other thing I should say is that the method of section says if the whole truss is an equilibrium, when we take a cut or imaginary cut, we can take either part. Okay, we'll choose, of course, the easier section or part, and each part will be also an equilibrium. So the unknowns, okay, the unknowns of the forces, we can apply these 3 equations to find them easily. Okay, so here in our case it's easier to take what? This part. Okay, so we need just the reactions at F, no need to find the reactions at A, ignore the reactions at A. So taking the summation of moments at A, we will have what? First of all, this force multiplied by the distance, and it's rotating counterclockwise, so it is positive. Okay, also this force multiplied by this distance, which is 3 meters. Also, it's rotating what? Counterclockwise, so it is positive. Okay. Here, the force is passing through point A, so it is 0. Okay, the distance is 0. Okay. Regarding this force, 40 kilonewtons, it's also rotating what? Here's our force. Okay. And the distance is what? 2 meters till this point A. Okay, and it is rotating. It's rotating what? Counterclockwise, so it is positive. So 40 multiplied by 2. Okay, and finally our force here, our reaction Fy, it will be rotating clockwise about point about point uh, A. So here is our force, here is our point A. So, and the distance is what? This distance is what? 4 meters, correct? And it is rotating what? Clockwise, so it's negative. So minus F1 multiplied by 4, we'll get Fy, the reaction at F, to be 57.5 kilonewtons upwards, acting upwards. Now, after taking the section, we can apply the equilibrium equations, but in most cases we can find one unknown using one equation. In other words, here, if we take the summation of moments about point H, okay, we will FEH, we will not include FEH and FGH because they are passing at point H. So we'll get easily or directly FED. Okay. Similarly, if we take the summation of moments about point E, both FED and FEH are passing through point E. So we will have one equation, one unknown, which is FGH. Okay. Oh, of course, we should not forget the external forces in the section or the part that we are going to choose after we make the imaginary cut. And we should, of course, include the reactions. So here the angle theta, we can find it easily from here. Here is the angle. We can say tan inverse this distance or length 1.5 over 2. Okay. So it will be 36.87. So taking the summation points about point H, as we said, we will just have this unknown. So FED multiplied by this distance, which is what given 1.5 meters. Okay. It's minus because it's rotating clockwise. Plus, we have also the force 40 here, and the distance till point H is what? 2 meters. And it is rotating counterclockwise, so it is positive. Okay, finally, this reaction, the distance is what? 2 plus 2, which is 4, and it is rotating clockwise, so negative. Okay, one equation, one unknown, and we'll get FED to be minus 100 kilonewtons. That means it's in compression, because we have assumed it at the beginning to be a tension force. Now, taking the summation of moments about point E, here, we have what? 40 kilonewtons will not be with us, and these three forces, okay? So that's why we are taking the summation of moments at point E. It will be much easier, and we will have one unknown only. So FGH multiplied by the distance, which is 1.5, and it is rotating what? Counterclockwise, okay? So it is our distance. So it is plus FGH1 multiplied by 1.5, and this force multiplied by the distance, which is 2, it's rotating, but clockwise. So it's negative. So minus 57.5 multiplied by the distance, which is 2. Okay, we'll get the value of FGH to be 76.67 kilonewtons, and it's in tension. Okay, so our assumption was correct. Now, finally, to find FEH, okay, we can take summation first in Fy. So we have plus F57.5 minus 40. Okay. Here it's only horizontal force. So here we can say, and here also it's a horizontal force. So here we can say FEH sine theta, but it will have a negative value. Okay, so minus FEH sine theta. And we will get FEH to be a positive, so our assumption is correct. Now, here the idea is that we have a hinge. When we have a hinge, we can separate. So we can say FBC, okay, because why? We have here a total number. If we take the whole free body diagram as the whole system, we have here a fixed support. So we have here 3 unknowns, Fy, Fx, and the moment. And here we have Fcy. So we have 4 unknowns. We can solve it. Here it's a 2D problem. We have 3 maximum number of equations. Okay. So the idea is that we have a hinge we can separate. So we can have one extra equation. How? Let's say here it's By and here it's Bx. Okay. So we have here 3 unknowns, correct? We can get bx and by, then we will move to the other part and we will like reverse the directions. So here it is, it will be bx and here it will be, sorry, here it's bx, sorry, in the opposite direction. So here it is bx and here it is by, here it is by, okay? So they are in opposite directions. Check here, it's bx. Here it's by acting upwards, here it is acting downwards, okay? So after we found bx and by, now, okay, we have this member AB, and here we have three unknowns only because we have found bx and by, okay? And we can solve it. So here we take member BC, okay? We have this load, so the result will be 4 multiplied by 2, which is 8 kilonewtons. It's acting in the middle, so 1 meter is 1 meters, okay? And here's our unknowns, bx, by, and cy. And finally, we will reverse, okay, the directions. So taking the summation of x, we will get bx equals to 0, and summation of fy, okay, we will have what? Or first of all, let's take the moments about point B, okay, about point B. So we have 8 kilonewtons multiplied by 1, and it is acting clockwise, so it's negative, plus cy multiplied by the distance, which is 2, and it's acting counterclockwise, so it is positive. So cy will be 4 kilonewtons acting upwards. Now, taking the summation of fy's, we will find by. Okay, so plus 4, which is cy, minus 8, which is the resultant, plus by, one equation unknown. Okay, so now we can move on to member AB. Okay, here we will reverse the directions. So by was 4 kilonewtons acting upwards. It will be acting downwards. So here it is acting downwards. Don't forget to reverse the directions. We have 10 kilonewtons and we have the triangle and the unknowns. So taking the summation of forces in Fx in the x direction, so plus Ax minus 10, 3 over 5, okay, minus 10 equals to 0, we'll get Ax to be 6 kilonewtons. Now, summation of Fy will have plus, or we have plus Ay minus 10, 4 over 5. So minus 10 is acting downwards, okay, and minus 4 because also it's acting downwards. So Ay is 12 kilonewtons acting upwards. Now, taking the summation of moments about point A, because here we will not include Ax and Ay. So MA, I've assumed it to be counterclockwise, so positive, and here the vertical component will be with us. So 10 multiplied by 4 over 5 multiplied by the distance, which is 2 till point A, and it is acting or rotating clockwise, so it is negative value. Okay, and finally this force by the distance, which is 4 meters. Okay, and it is acting or rotating also clockwise, so it is a negative, and we get the moment at A. Okay, clear? Now our final problem is about frames and two force members. Now a frame is different from the truss. The truss is only we only have force members, so we don't have any load in the middle. But a frame, we have at least one member having a force in the middle. Okay. So identifying the two force members from the beginning will be a good idea. Why? Because here, let's say we have 4 reactions. Okay, so we can solve it. But as soon we have identified this as a force member, two force member, we can say, okay, we can replace it by FR and an angle theta. Okay, let's say here an angle theta we can find. Okay, so we are left with what? How many unknowns? Only 3 unknowns, Cx, Cy, and also we have the external loads here, E and W, and Fr. So from 4 unknowns, we have reduced the unknowns to 3 unknowns. Okay. So that's the idea. Now here we can note that this is a two force member because here it's only pin and here it's only pin and we don't have any forces here. Okay. So we can replace it by FAC, the resultant, because here CY and let's say CX, and here AX and AY. So we can say, okay, we will put here a resultant FR, and here let's say resultant FR, and we can find the theta, the angle theta. And here what we have did here, see, we have replaced the, removed the two force member, and you have said here is the resultant FAC. So here is the resultant FAC. Okay? FAC, the force. And here is the triangle, it's given, okay, 4 and 3 meters here, and we can find 5 meters. It will be here 5 meters, okay. And here, check, we are left here with only 3 unknowns, Bx, By, and Fac, and the resultant is in the middle, 8 kilonewtons of this uniform load, okay. And we can now find, or use our equation, summation of moments at B, okay. We will only have the minus here, the horizontal component, which is FAC 3 multiplied, FAC multiplied by 3 over 5. So FAC multiplied by 3 over 5, okay, multiplied by the distance, which is 4 meters, okay. The distance, vertical distance is 4 meters, and since it's rotating clockwise, it is negative, okay. And also we have the 8 kilonewtons multiplied by distance, which is 2, and it's rotating counterclockwise, so it is positive. So we'll get FAC to be 6.67 kilonewtons. Now, to find Bx and By, okay, we can say, okay, taking the summation of moments about point C, which is here, uh, sorry, Bx, okay. We can say first, we can find, like, okay, you can start from either, from as you like, okay. So summation of moments about point C, here is point C, okay, let me erase this. So taking the summation of moments about point C, okay, we have the force Bx multiplied by the distance, which is 4 meters, okay. And then we have minus 8 kilonewtons multiplied by the distance, which is 2 meters, okay. Here the 8 kilonewtons is rotating clockwise, so it's negative, and here the Bx is rotating counterclockwise, so it is positive, okay. So one equation I know we can find Bx, and taking summation of forces in the y direction, we can get what? Here we have positive FAC multiplied by 4 over 5, okay, and FAC is 6.67 minus By, okay, minus By equals to 0, so By will have it to be 5.34 kilonewtons acting downwards. Now, what's required is to find the reactions at A and B. We have found B, correct? We have found the reactions at B. We can say, okay, now we can consider the whole frame, okay? Now we are left with only 2 unknowns, or you can say, okay, I will take the summation of forces on joint A. So here I have, okay, AY, AX, and FSC. FSC is unknown. FSC, I've assumed it to be tensile, okay? So here it will be like this, FSC, okay? But here I took the whole frame, so summation of forces in the x direction equals to 0, so plus AX plus 4 minus 8 equals to 0. Okay, so AX is 4 kilonewtons acting to the right, and taking the summation of forces in the y direction, we will have plus AY minus 5.34 kilonewtons. Okay, so AY is 5.34 kilonewtons acting upwards. By this, we conclude our tutorial. Okay, thank you for watching.